Hi, welcome back to another episode of FRC Robotics 101. It's me again, Tang, and as I've said in the last episode, these two episodes are going to be about the pre-brainstorm process, the process of research and preparation that has to be done before the actual competition. So we're going to talk about how and what to do your research on, how to build your strategies, and how to establish your goals. The goal for the whole process is just to get all of the research and preparation done as soon as possible, even before your competition. So I've seen a lot of teams just ignore this process when they actually have the time and only start doing research when their season started. This is not ideal. They will waste a lot of time in their seasons, the time that they don't actually have. And also, they are going to be stuck doing a lot of revisions because their decisions are not informed. They're not sure of the things that they're deciding on. But if you can get all of these done beforehand, you can save the time that you would need doing research. Furthermore, all of your decisions will be informed, which means that whatever you're deciding on, you're sure that it would work. So you don't have to go back as much. This process is really what makes good teams stand out. So why is research in competitive robotics so effective? The thing is, in most competitions, the tasks you're asked to do have been done before, even in your competition. Let's take, for example, Abu Robocon, one of the largest robotics competition for college students in Asia. Their 2020 game and their 2019 game both include the task of the robot picking up an object, navigating through a path with that object in hand, and then throwing it to a small specific area. For the FRC, the 2018 and 2019 games both include the task of the robot picking up a large object, using whatever elevation system to bring it up high, and then drop it to an area up high. So as you can see from the examples, most of the tasks have been done before, which means that you can do research on those. You can do research to know what kind of task you're going to face and what kind of mechanism that you should do when facing each task. Moreover, you would need to do your research on specific mechanisms. And when I was just starting out, I was asked to do research on shooter mechanisms. What I got from my research was a two-wheel shooter, a one-wheel shooter, or a flywheel, and then a catapult. But when I was asked why I would like to use the one-wheel shooter, I had absolutely no idea. And that's what I want you to avoid. When you're doing research on mechanisms, you should note down the pros, the cons, and what each mechanism goes well with. So let's take, for example, the flywheel. The pros of it is that when you're shooting out, it's very consistent because the flywheel is very heavy, which means that the speed of it is not going to change much after you're shooting a game piece. Another thing is, because you're only using one wheel, it will add backspins to the ball, so when it touches the back pad of the goal tower, it's going to fall immediately down instead of bouncing back. But the cons of it is that because you're only using one wheel, it's not going to shoot that strong, so it will lead to the path being an arc instead of a straight line, which means that it will limit your range and it will make you do a lot more calculations. But it can go well with many effective mechanisms like the Wheel of Doom. So that's also a good point of it. So for each mechanism, you should note down things like that. So another thing to do your research on is the services you have available to you. This kind of research is going to take a long time, so please do it beforehand. The services can come in the form of support from experts, shops and materials that you can buy from your area. It can be locations that you can build your robot or test your robot, and it can be manufacturing services. For shops and materials, you just need to do a Google search. It's not that hard. But for the support from experts, manufacturing services, and locations, as a student, you don't have the money to do it. So it means that you would have to ask from your connections, and even your connection that you get from your connection, and getting it through connections will take a lot of time. Let's take, for example, the factory that we're using right now, it took us 3 years just to get in contact with the owner of the factory. And it will likely take you just as much time. So please do all of this research way beforehand and don't wait until your actual competition. So after doing research on the kind of materials and the kind of manufacturing methods that you have available to you, you should also do research on the characteristics of each manufacturing method and each material. So for now, let's just talk about materials because that's going to be what's immediately helpful to you. So the most common materials in competitive robotics are wood, 3D printing filament, and then polycarbonate. So let's start with wood. So wood is one of the most common materials that you can find around you. You can just find it in your area, find it basically anywhere, just look around you. The thing about wood is that it is pretty hard. It is also very easily manufactured. You can make basically every part out of it without spending too much time. But the thing about it is that it's very heavy compared to things like box aluminum and also compared to sheet aluminum. And it is very easily worn out. As you can see, the surface of wood after a while will be very scraped and it will basically just not work after a while. So you don't want that to happen to your actual robot. But being easily manufactured, wood is very good for building prototypes. Then we can move on to the king of materials in competitive robotics. That is aluminum. Aluminum is generally very hard and pretty light compared to other metals like steel. And one additional thing that is very good about it is that it doesn't rust, which means that after a year or two, your robot that is made out of aluminum would still work. And that's a good thing. But when you're considering using aluminum, one of the things that you should know about is the different kinds of aluminum that you have available to you. The first kind would be sheet aluminum. Then you would have box aluminum, and then shape aluminum. Let's first talk about sheet aluminum here. So as its name, it comes in a sheet, and then you can do whatever you want with it. You can cut it out, bend it, do whatever. You can make different kinds of parts with it. Basically, if you want to make a part, you can make it out of sheet aluminum. It's just that versatile. But the thing is, you would need CNC machines to build parts out of sheet aluminum. Except for things like gusset, yeah, you would need a CNC machine. And that would be pretty expensive. So that's why you should consider other things like box aluminum. Box aluminum is very light for an extrusion because its wall is very thin. It's just a hollow out extrusion of aluminum. It's not a solid thing like you would have with wood. This makes it very light, but still hard enough for anything you would need. Another thing that is very good about box aluminum is that it's very common. You can basically buy it anywhere. And yeah, you can easily manufacture parts out of it. But it is still just an extrusion, which means that you have to be pretty creative if you want to make a curve or any weird, complicated part out of box aluminum. Then you can move on to its heavier but easier to use cousin, that is shape aluminum. Shape aluminum is a lot heavier and it's also a lot harder. It's not hollow out all the way through. It is generally thicker, but it has grooves and holes in it, which means that you can have parts that are pre-made that is fitted for shape aluminum. If you don't have the time and your robot is not weight constricted, you can use shape aluminum because it is more convenient just to use this. Then we can move on to 3D printing filaments. This is an example of a part that we 3D printed. This is made out of PLA, which means that it is pretty crumbly. As you can see here, we can just bend it a bit and it will crumble. But 3D printing filaments can range from being very brittle, like PLA, to being very, very hard and heat resistant, like polycarbonate. It just depends on what kind of filament you have available to you and what kind of filament your 3D printer can use. Each time you upgrade your filament, it will be harder, more heat resistant. Sometimes it will get an additional characteristic, unlike others. But each time you upgrade it, you would also need to upgrade your machines. And the material itself will cost a lot more. So you would need to balance this kind of material before using it. Then the final material is polycarbonate. Polycarbonate is the kind of material that you would not consider when you're starting out with competitive robotics, because it is the thing that is often used in clear roofing, and basically you never see it in robots and machines. But for competitive robotics, it's pretty useful. It is very flexible, which means that if your part needs to take stress, but you don't need it to stay in place, you can use this. It's very useful for building walls and guiding paths. It is very useful for building walls and guiding paths, and generally just a lot of things, and especially for building electrical board. So that's it for this episode. So we've went through how and what to do your research on, and we've went in depth about the materials. The next episodes, we're going to talk about how to build your strategies and how to establish your goals. Thanks for listening and watching. See you next time.